o'clock. I can slow start while we're still waiting for people to join. For all those who are already here, very welcome to today's EGI webinar. Just a short, very short introduction of what we do. This program is designed to equip the EGI community with valuable insight into the latest EGI services, cutting-edge technology development, and advanced scientific tools. In 2024, we are focusing on key emerging topics, including artificial intelligence, machine learning, GPU technologies, green computing, cloud solution use, and data space. Our goal is to bring you leading experts in this field to share their knowledge and provide valuable perspective. And the EGI webinar series not only foster discussion, but also offer a platform to showcase advanced service solution and best practices. If you're interested in promoting your own service, we encourage you to reach out to us. Before we begin, let me go over some housekeeping rules to ensure a smooth and efficient session. Keep your microphone and video off unless you are giving permission to speak. Submit your question to the Q&A box at the bottom of the Zoom window. You can find a button. We will have a Q&A session after the talk, where you can engage with Łukasz directly. To participate, you please use the raise hand button. This webinar will be recorded. After the session, we kindly ask you to complete a short survey to provide feedback and help us improve our program. I'd also like to mention that you can stay updated by visiting the EGI training and webinar website, where you can find the details on upcoming events. If you missed the previous talk, recording are available on our YouTube channel. If you would like to request a special webinar topic or contribute by presenting one, feel free to email us at support@egi.eu. Don't forget to subscribe to our mailing list so you won't miss any webinar announcement. Sorry. Okay, sorry. Now I'd like to take a moment to introduce the EGI Access Core. This program offers a wide range of EGI services alongside user support and training tailored for various groups, especially for individual researchers, national and international research projects, research communities, research infrastructure, commercial research entities. The EGI Access Core is designed to meet the various needs of this group, helping to enhance research capability through EGI service. And today's webinar is a DataHub, an innovative platform for ingestion management and publishing of distributed scientific data. We are honored to have Łukasz Opioła as our speaker today. Łukasz is a researcher and a team leader of the Onedata project as the laboratory of cloud technology CYFRONET. He's also a PhD candidate at the Academy Computer Center of CYFRONET at AGH University of Science and Technology in Krakow. And Łukasz has been involved in a number of Polish and European research projects and is a key developer behind Onedata. And his expertise lies in virtual file system, distributed and decentralized architecture, data access control, and AAIs. Thank you, and hope you find today's webinar informative and engaging. And now I give the floor to Łukasz.
Thanks for the introduction. I'm very grateful for this opportunity, and I hear there is quite a big audience, which is amazing, and I hope you will enjoy the next hour. This webinar will be about DataHub, an EGI service for distributed scientific data management. It will be mostly about the advancements and improvements that we made during the last year, but I also assume that some of the audience here may be new to it, so I will try to give you enough background and explain how it works and what's its purpose. To that end, we'll start with a brief introduction to DataHub and Onedata, the software it runs on. And for the rest, I've broken down the contents into 3 chapters, covering together the comprehensive data management capabilities of DataHub. I want this webinar to be very interactive. So in every chapter, we'll have a couple of slides, then a demo, and I thought a short Q&A break to answer questions on the spot. Is this possible technically to have small Q&A sessions in between?
Mm-hmm. It's
Okay.
your choice, yes.
Okay, great. So we'll do it like this. And I guess the Q&A questions will appear in chat, or how does it work?
Yes, you
Yeah, I can see the Q&A box now. Okay.
box, but if for the more interactive, we can allow people to talk if they can raise hand, and then we can enable them to talk. So
Okay, all clear. Thanks. And so here we go. So to introduce DataHub, I should start with Onedata. And Onedata is a data management platform that aims to unify access to geographically and organizationally distributed data. These days, achieving scientific progress requires the sharing of data between autonomous providers, organizations. The data is geographically distributed and lying on heterogeneous storage systems in different sites. And to unify access to the distributed data, we introduced the concept of spaces. A space is a virtual logical volume for data. From the user's perspective, it's a single logical namespace, but the physical contents of the files can be distributed among different storage systems and data providers. Users and working groups of different affiliations can be granted access to the spaces, allowing distributed collaborative data sharing. And of course, the groups themselves may bring together members from different organizations or contain nested groups that build a hierarchy. And that's all realized by our one provider component. So Onedata is an open source project. It's not a global service. It's a software stack that you can take and install on your own infrastructure to run an isolated environment or become a data provider as part of a bigger installation, for example, DataHub. So we have 2 main components that are OneZone and One Provider. OneZone coordinates a single environment made up of any number of one providers, while one provider is installed at every data provider, the data site to realize data access and management tasks, cooperating with other data providers under the same zone, of course, given that they share common spaces. In recent years, there have been usually 5 to 10 active Onedata zones, depending on project life cycles. These are the ones we know of. Since it's open source, there can be more. One interesting installation is the one for the Polish National Museums, where Onedata serves as distributed storage for digitalized museum data kept in different sites. And in this project, we are looking at about 10 petabytes of data and in 100 million files. EGI DataHub is a long-haul Onedata installation, bringing together 18 sites from around Europe. Currently, there are over 2,000 spaces with over 2 petabytes of allocated data, serving over 800 users. Most of the spaces are related to scientific projects run by international consortia. DataHub is tightly integrated with EGI check-in, allowing seamless access for EGI users. A very useful feature is the reflection of EGI's VOs and groups upon login. It happens automatically, and users don't have to perform any extra steps to easily work with the same people as they do in EGI and other EGI services. And SSO integration and group mapping is not specific for EGI, but a generic mechanism in Onedata, which supports standard OpenID Connect and SAML 2.0 protocols. And DataHub is a production service in the EGI portfolio. Okay, that's it for the introduction. So now I would like to show you a quick demo with an overview of the DataHub service. So I'm opening EGI DataHub EGI EU. Here is the login page. I can log in using my EGI check-in account. My information will be propagated. And here I am. So this is my list of spaces. It's quite large because most of them have been inherited via the groups from EGI. And since I am an admin of the service, I have access to lots of groups. So the list is quite large. And this is my view on the providers supporting my spaces. Some of them are currently offline. And I think so I will now log in into an account where is much less stuff going on, so the demos are clearer. So I've created a special webinar account where I have access to 2 spaces, and here's my webinar space created specially for this webinar. Currently it's empty, but we'll make it more interesting. There are 2 providers supporting the space, so providing storage quota for the data. And basically that's the first overview. There will be more happening in the next demos. And by the way, here is the design of the new EGI login page that's more unified with other EGI services. It's coming soon. So I think in a month's time, you should see that when logging into EGI. Okay, so that's for the very basic introduction to DataHub and Onedata. First chapter is ingestion. So there are multiple ways data can be ingested into the Onedata system. And we can roughly divide them into 2 classes, pushing and pulling the data in the system. For push, we have upload through the web GUI, supporting upload of whole directories, the REST API, Onedata RESTFS, which is a new thing. It's a lightweight PyFilesystem plugin that I will demonstrate in a minute. Then we have the CDMI API. Let's say it's similar to REST, but with different semantics. We have one client, which allows you to mount Onedata locally in your file system. It also allows performant direct access to storage data in certain setups. Onedata FS is a counterpart of one client in Python. So it's a heavyweight cousin of Onedata RESTFS. It has a lot of dependencies, as it has to include drivers for different storage systems to allow the direct storage access, while Onedata RESTFS uses the REST API behind the scenes for all operations, so it has minimal dependencies. And then there is the S3 interface, which is currently in beta. You can use any standard S3 client to manage your data in Onedata. And moving on to pull methods, the import engine makes it possible to scan existing data sets and import them into a Onedata space. No data is copied in the process, only the file metadata is registered. The import engine can also work in a mode where files or objects come from external storage, and they are registered by space users. Again, this only creates a link to the external data without copying it. Finally, there is the automation engine that I will also show in later demos. It talks to a Kubernetes cluster that's running alongside the provider cluster and allows you to run arbitrary user-defined lambdas functions. These functions can do pretty much anything. Process the data, or populate the space by producing some data or fetching it from somewhere else. Lambdas have access to most of the APIs, and the Lambda pod in Kubernetes can have the Onedata file system mounted locally by means of one client instance running in a sidecar container. Of course, all the interfaces on the left-hand side are not only for data ingestion, but in general for data access and management. So in the next demo, we will focus on what's new, the Onedata RESTfs and the S3 interface. Okay, so for the demo, I'm going back to DataHub now. To use the interfaces, I'm gonna need an access token. So I will create one now. I will pick up the one provider REST template to start with, but we don't want to limit to only to REST because we're gonna use it for S3 too. So I'm just gonna create a token for a one provider access, copying it to clipboard. In the meantime, I can go back to my files. Okay, so the space is currently empty. And what I want to do is use the S3 interface to upload some data to the space. So I'm going to use rclone to that end. So here is my rclone config. I'm putting down the access token. And yeah, it's currently in beta, and one of the things is the token management. So for now, we use the token for both access key and secret key, but this is something we are working on, and we plan to have users be able to generate secrets linked to specific tokens. But for now, it works like this. So we can see that the type of this rclone is generic for different storage systems. So we pick the S3 type, put down the config. Here is the endpoint. So I'm using my webinar provider, and this is not very interesting. So I'm not going to talk about that. So I've saved my config. I have that data set lying on my computer. It's very simple. This is the data set. It has a README and a bunch of photos inside. And I want to upload this to Onedata. So what I'm gonna do is run rclone, supplying the config, parallel transfers, and copy the data set to my endpoint that I have specified in config, and to the webinar 2024 path, MySpace here. So it's should start now, and we should already see something popping up here. The web file browser is now quite reactive. It automatically updates the list of files when something changes. Yeah, so the upload is complete. We can now use some different S3 client to see the contents of the space. So let's use AWS CLI. I'm configuring my access and secret key again. Region is not important, and I can list the contents of the space. So this is the endpoint, and I'm saying the webinar with the path. So I'm listing the whole space recursively, and we can see what we uploaded using rclone. Yeah, so now we can, for the OneData RESTFS, let me run a Docker with Python 3.12. Why not? So all I need to do is install the OneData RESTFS library. It has minimal dependencies, so it's quite lightweight. Should be quick. Yeah, so most of the packages here are related to requests and the PyFilesystem library. So it's quite minimal. And now I can run Python and see what happens. So all you need is the token. This is the token we saw before, and the domain of the ones on service. That's all you need to access all your data from the level of PyFilesystem, and we can now easily, for example, list the main directory, which will show me the spaces I belong to. I can list, for example, the photos directory inside my webinar space, and this is it. I can write something. So let's write a simple text file with hello webinar content. It should pop up in a second in the space. And that's it. So we have used S3 and OneData RESTFS interfaces to OneData to do some simple operations on the space. And that's it for this demo. Moving on. Yeah, so right now we have seen the two new interfaces, but I also have a little teaser for you. Our colleagues from the Czech Republic are working on a Windows sync and share client for OneData. So here you can see an actual screenshot of a working prototype. So just like Google Drive, OneDrive, Dropbox, you can get a nice OneData location in your Windows Explorer, and you can manage your data native on Windows. On the right, you can see the OneData web GUI showing the same space. So it's all a work in progress. We hope it will make it to production and be available for everyone. But we'll be happy to hear how many people are interested in that, so we can put the right priority on this project. Okay, so we can move on to the next chapter, which is data management. So in this chapter, it's less talk, more demo. I want to show you our evolved UI, improved automation workflows, our recent integration with the Galaxy platform for life science, and finally, we'll have a showcase of the EUreka3D project. So without further ado, I'm going back to EGI DataHub and to my webinar space. The first thing is customizable file browser columns. So using this menu on the right, you can decide what information will be shown for each file. And we have added quite a lot of new columns. So let me enable some of them. Okay. You can reorganize them. So drag and drop, change the order. You can also do it here as well. And yeah, so you can have as many as you want, but of course it's not gonna be very clear because there's a lot going on. So maybe some less. To make this a bit more interesting, I want some more files in this directory. So I'm going to run a simple script that does a couple of REST calls. This is a script with some access tokens of different users and just some REST calls that will create some files to make it more interesting. Running it right now. The files are created on a different provider, so it can take a second. Yeah, it's gonna keep overwriting the Omega file. Okay, so the more interesting columns are replication, where you can see the how much of the logical data is held on this provider. We're currently on the webinar provider. There is another one. So for this file, for example, it's completely located on the other provider, but this one is kind of split. So this can be quite useful. Then there is the quality of service column. And here we can see what quality of service rules have been applied for this file. They were created by the script. So this one says that we want 2 replicas on any storage, and it has been replicated to both data providers according to this quality of service rule. This one will keep on being ongoing because I'm modifying the Omega file in the background all the time by the script. And this one cannot be fulfilled because I asked for 3 replicas, but I only have 2 storage systems supporting the space. Okay. And now, to make it a bit more interesting, there's another nice column. It is not yet in production release, but I'm a show-off, so I've deployed our development version of webinar on this webinar provider, so you can see it. And you can configure a column that will show the value of an extended attribute for each file. Right now, due to the fact that it was uploaded using arclone and S3 sets some basic extended attributes, so I can, for example, show the content type for every file. Maybe go to photos, and yeah, so we can see this, it's all image JPEG. And to make it a bit more interesting, I will show you what you can do with automation. But let's unclutter this view a bit because there's a lot going on. So maybe we want, yeah, maybe like this. And now, it's super easy to run a workflow from the file browser level. So you can either run workflow on this file here. You can run a workflow on the whole space, which I'm gonna do. And I want a workflow called calculate average image colors. So I'm gonna pick that one. It has one input, what files should be processed. I'm saying process all the webinar space, so everything in it is gonna go recursively inside and run the workflow for each file. So I'm running the workflow. It's super easy. It's only one step. A lambda called calculate average color. We can see it's already running. Some files are in processing. We can view the pod's activity. So what's going on Kubernetes related to this workflow. We can see an audit log with some useful information. If there is something failing, you would see that here, which would help you debug. And yeah, and this, what happened in this Lambda, basically when you create your Lambda, you have to write a Python handler that will perform some operations. And the most important things here is I've created a very naive algorithm that will just take all the pixels and then just take an average color out of them and try to map it to the closest name of the color. So it's not very advanced, but yeah, and then I just take this closest color and set an extended attribute with the name color. I have the Onedata file system mounted on this container, so I can just use the local file system to interact. So I'm just using the built-in extract xutter command of POSIX and of course the Python wrapper over it. But basically just reading local files and setting extended attributes on them. So that has been run for every file. And now we can go back to our files and see I want a new extended attribute column color. So now it sees it because some files are have this extended attribute set. Maybe I want this up front. And here we have a color computed for every image in this directory. Let's see. So for example, this is maroon, so dark red. Let's see this file. Yeah, works. So this is the averaged color of this is dark red, and this is what my algorithm classify how it classified this. Okay. Of course, it's not gonna work for everything because it's very naive. So yeah, here we can see that this image is yellow and blue. So after averaging, it's olive. So it's not perfect, but you get the idea. You can having a well annotated data in your space. You can customize the file browser and make your life much easier. And so this is coming in version 21027, which is just around the corner. And you can also expect a JSON metadata column. Maybe not that soon. It's a bit more complicated because we want to have a nice query builder so you can kind of look into complicated JSON terms and structures, but you will be able to take out some information from the metadata and have it right in front of your eyes in the web browser. Okay, another thing is the API samples. So when we go to information, there is this tab that shows you ready to use API samples, so some curl examples, how to use our REST API with the file ID already filled in. So I can, for example, download file content, and this is the command I need. All you need is to export the token. So let's do it. I'm exporting the access token I've created before, and just copy this command and paste it right into the terminal, and I can see my hello webinar content that I have written using the Onedata RESTFS. And of course, there are more operations here. So for example, let's get the data distribution of this file. Maybe pipe it through JQ. And this is the data distribution. So what we also saw in the UI, graphically presented, we can also get with the API. And this is quite nice if you're writing some scripts or middleware and gives you a kickstart. You don't even have to read the docs to use the API, which is the dream of all developers. Yeah, and then we have also another handy thing are info popovers all around the system. So we have this little icon that gives you a shortcut to the information about specific resource. So about files, about the webinar space, I can see the space info, I can see some REST API examples for the space. I can see info about the provider, about the members. So we're trying to get it all over the UI, so it makes it clearer and easier to understand all this, all that's happening here. Okay, that's it for this demo.
We have a question in the
Mhm.
Q&A box, and can you see the box or can I read for you?
Yeah, I can see the box. Thank you. So I'm okay. So let's start chronologically. Thank you for the questions. So data can be copied or moved within the same space in a regular way. What is the best method to copy data between two spaces? So currently you won't do that using the web UI. It's not possible. I think the simplest way would be to use one client to just because it's kind of agnostic to the spaces, to just copy it from one space to another, and it will do all the required work behind the scenes for you. But you could use most of the APIs for that. Maybe there will be a time when you can do it from the UI. Yeah, so yeah, if the data is big, maybe you don't want to move it through your computer, so download and upload, and then using the APIs could be better. Okay, the next one is what language is used to write workflows, and I guess it was asked before I showed the handler in Python. Basically, we are using currently we're using the OpenFast engine which allows different languages to be used. For now, we have only used Python because we didn't have use cases for anything else, but it can be done. So if we have such needs, we can have different languages. The next one is the column view with defined metadata will be saved for a specific user per specific space. Yeah, it is saved in local store of the browser, which means on this computer in this browser, it will be retained between logins. But if you use another computer, you will have to do it again. Maybe if we have some very complicated JSON ones, we'll give an option to save your setup and import it, or maybe save it on your Onedata account. We'll see how it evolves. Okay, these are the.
We have another question from Irina in the chat.
Okay.
How would you download several files at once?
So right now you can download tarred directories, so the whole directory will be downloaded. So yeah, I will just download an archive that contains all the photos. I don't think it is possible. Oh yeah, it is. Sorry, it is possible. Yeah, you can just select with Shift couple of files and then just download tar, and you will get a nice archive with what you selected. Okay, thank you. I'm moving on. Oops. Yeah, and now for the Galaxy integration. Let's just a quick look. Galaxy is a platform for data analysis using workflows, mostly life science, but not only. And in the scope of the Euroscience Gateway project, we have integrated Onedata as a storage layer in Galaxy. I will not go into detail here, but basically this allows users to bring their data sets from Onedata to Galaxy, and for the Galaxy scheduling logic to schedule in a smart way considering data distribution, because Galaxy also uses a distributed network of endpoints that run jobs. We have a distributed file system here. So in this project, we are working on kind of making it talk to each other and embrace this data distribution and this knowledge of distribution. And I'm just gonna show you a quick look. So this is the use Galaxy.eu. So this is European Galaxy instance that's also being developed in the ESG project. In my preferences, I can put down again the domain of one's own service and my access token, and that's enough to be able to import your Onedata data sets to Galaxy. So I can see my spaces and I can import, I don't know, those photos that I've uploaded there. And the other option is to add Onedata as so-called object store, which means that the Galaxy data sets, not the one so the ones that are being processed in Galaxy after importing, will be held on your Onedata account, which allows you to extend your user quota in Galaxy. Okay, I think that's it, and we can move on to the EUreka3D project that's run by EGI, of course, in a big consortium when we also take part. This project is aimed at high quality 3D digitization of cultural heritage, monuments, sites, museums, museum objects, and others. And it contributes to the digital transformation of the field, providing services and tools, many of which are based on the DataHub service. And so this is an overview of the whole flow, starting with a cultural heritage object, which in this case is Lambuza fishing trawler. It goes through digitization, annotation, upload to the cloud, publishing, and finally it can be viewed and downloaded by the users. It can be found using a browser. And the role of DataHub in this project is firstly organizing working groups. So thanks to check-in integration, it's a seamless process. Group setups from EGI are propagated, and then multiple organizations that upload the cultural heritage objects in digitalized versions work in the same space. They upload the accompanying files and all that's needed. It's all backed up by granular access control, which I will show in a second. Then there is metadata curation. We have created a rich editor for Europeana Data Model. That's also going to be shown in a second. And finally, publication as open data. So public sharing of files and data sets from the space. Onedata gives you automatic persistent identifier minting, PIDs, DOIs. In Eureka, we are integrating with B2 handle, but this is quite generic, so any provider can be used. And finally, it is exposed via the OAI PMH protocol for harvesting by Europeana. And I'm going to show you what it looks like on DataHub. Here is the EUreka3D space. In the main directory, you can see directories for different CHO objects. Among the members, we can see the groups that were propagated from EGI. And all those users in this space have inherited access via those groups as assigned to their organizations. So we have group for Photo Consortium, Museum de la Carta, and so on. And right now I'm going to switch to the webinar space to show you some things in action, because we don't want to make a mess in the EUreka3D space. But for the purpose of EUreka3D, we have created a specialized workflow for initializing project structure. So this is the initialize EUreka3D project workflow. I'm going to run it in the main directory, and all you need is the name of the project and what groups will be managing this project. So I'm gonna pick some of the groups, let's say EGI and Photo Consortium, and I'm running the workflow. And here you can see a bit more steps than before, but it should go quickly anyway. So it's gonna create a project structure and set some ACLs. Let's go back to the main directory. We can already see the directory for our new project. ACL should pop up quickly. So here we have the groups that we have designated to manage it. Only the members of those groups will be able to modify this directory and to access and modify this directory. Inside we have a predefined structure that has been created by the workflow. So thanks to this, we can impose unified structure of CHO data sets in the space, making it easy for the users and having everything in order. And what's important, looking at those workflows that we have run, but having this, since Lambdas have access to the Onedata file system and all the APIs, it's possible to achieve pretty much any functionality with it and tailor it to the needs of specific users or projects. Basically, sky is the limit. You can do whatever you want with it. All right, so moving on to chapter 3, publishing and okay, there has been a question, which role can create edit workflows? It basically depends on your privileges in an automation inventory. So we have the idea of inventories. An inventory basically holds workflows and lambdas, their definitions. And you, just like in spaces, you have members, and just like in spaces, but differently, they have specific privileges. So you can say who can manage lambdas or manage workflow schemas. Basically, in an inventory, you would have a group of people who are producing workflows and a group of people that are using them, because you need some technical background to create a workflow. Of course, you can also give those permissions to the whole group of users. And for the second question, there is a working Onedata instance in France, it seems. Who is it? Are they here? That's a good question. That's a good question, and I'm not sure which. Let's see. But I'm gonna. Okay, you know what? Let's keep it for the last Q&A session, because I need to check. So we'll do it later. And oh yeah, sorry for that. So we were here, and now we're moving on to publishing and archiving. So in Onedata, we have a concept of shares. Shares are a semi-public link that allows unauthenticated read-only access, but I call it semi-public because the link is impossible to guess. So you have to give the link to someone for him to be able to access the data in some way. But yeah, the access is public and read-only. It can have a description in Markdown format. It's possible to have one or more shares for a directory or for a file. And then you can have an open data record, which is basically a share extension. So it has built-in PID-DOI minting, and we have extensible plugins for different providers. The link is public and findable. It has standardized XML metadata attached. So the leading standard is Dublin Core, but for example, for EUreka, we have implemented the Europeana Data Model. And but all the time the underlying share is retained, so you can still use it as a share, but there is an open data record pointing to it, and it's exposed for discovery via the OAI PMH protocol. And this protocol, which stands for Open Archives Initiative Protocol for Metadata Harvesting, has the notion of repositories and harvesters. And here, one data instance acts as a repository that is scanned regularly by harvesters. And of course, there can be many harvesters, but in the EUreka3D project, it's Europeana. So it's a digital library for European cultural heritage. Users can browse through records aggregated by Europeana. It's also possible to download the 3D models served by DataHub, since the metadata contains proper links to where the data is stored. So there's a link between those two. Okay, I will now present the publishing process from the level of DataHub. So again, to webinar, because we don't want to meddle in the EUreka3D space. I'm entering the project structure of Lambuza fishing trawler. I have a ready to use packed 3D object here, so I'm uploading it using drag and drop. And I'm using the share publish action, so I can say I want to publish it in one go. Create a share and publish in one go, maybe call it like that, and create. So the share is created, and now I'm in the publishing wizard. That's gonna, here I need to choose a service that will issue my PID. I've created one for the webinar, although, for example, our EUreka has a production B2 handle account that handles all, that mints all the PIDs, but we don't want to use production here. And we can choose the type of the metadata. So there's the standard doubly core, but there's also our Europeana data model. And the next step is filling in the metadata. And it's quite a big form because the EDM is a rich, quite rich standard. So these are only mandatory here, but you can add some optional ones. And we're not gonna do all of that, but basically each field can be different, but you can have literal values, references, so URLs. You can choose a language. Some fields can be duplicated. Some fields are automatical. Some of them have predefined values you can choose from. And you can also switch to the XML view. So you see the XML metadata that's translated one-to-one with the visual form. And to make it faster, I will just take a ready XML and paste it. So I'm pasting it here, apply, And now it should be synchronized with the visual form. So it just shows the counterpart of the XML source that we saw. And since we have filled in everything, we are ready to publish. And this open data record has been published. We can see the public handle link registered in the speed service. This is the public and the public PID being also the URL I can use to see it in an unauthenticated mode, which we are gonna do now. So incognito, opening the link, it resolves to the public share link, and I can see the metadata I have put down, a representative image here, and I can browse the files. So it's not super interesting because we have only shared a single file, but you can of course share a whole directory and its contents. In the context menu, I have some handy operations. We also have the APA samples. So I can, let's see, for example, get attributes of this file. And here I don't need a token since it's open and public. So I'm just gonna pipe it for JQ and I can see the this file attributes fetched using REST API. Okay, so now let me show you the OAI PMH endpoint. So this is also served by DataHub. It talks XML, and basically here you have the query I'm performing. So I want to list records of type EDM. And at the very end, because it's ordered by date, we should see our Lambuza phishing trawler created for demo purposes. And this is what metadata aggregators see when they scan DataHub for new. So they can pick up all this information, all this metadata, all those links to the data and to visualizations we'll see in a second, and present it on their page. So let's look at Europeana. And here we can see two data sets harvested from DataHub from the EUreka3D space. Here is the 3D visualization. So it also works automatically because all you have to do is share the zip file with the 3D object packed. And there is another service running in EGI that there is a link to this service inside the metadata. So it all happens, you don't have to do anything and you get your object visualized on the Europeana page. Here you can see all the metadata that has been gathered from DataHub. So this is basically what has been put down in the form. Okay, that's the end of this demo. And we can have a short Q&A break. Let's see. Okay, so if you need to run a Lambda that needs a specific Python library, should this be installed every time? Okay, that's a good question. Give me a second. I tried to show you. Let's do it. So this is my code editor. And here I have the calculate average color mounted Lambda. All I need is a super simple Docker file based on Lambda base, the handler, and requirements.txt file. And here you put down all the requirements. And then when you build the Docker, these are automatically installed inside of the Docker image that will be run on Kubernetes every time the Lambda is run. So it's kind of done only once during the building of the container. For the next question, aren't there plans for a public share for writing as well, anonymous file upload? So we did get this question before. Currently, we don't plan it unless we will have kind of a bigger use case. So somebody wanted to use it with a good explanation why, because there are different ways. You can, for example, create an access token that will allow writing only to one directory and just share it with people so they can take it and write some files to your directory. So this way you can kind of achieve that. So before we don't get a nice explanation why to do it, we are not planning it. But it is also always good to talk about use cases. Okay. I see that, yeah, there is a plan to extend this webinar a bit. I'm okay with that. I don't see more questions now. So I have one more thing to show. Should I do it or should we? Okay, if we have time, we can do it. So let's go with archives. So there was publishing. Now there is archiving. Okay, so we have this idea in Onedata of data sets. We call them directories on steroids because it's basically a directory in the file tree or a file, but it has some special additional functionalities. So it offers data and metadata protection. It can have a hierarchical structure, so we can nest a data set in a data set. Of course, so it depends on users of the space. What is a data set? So it's really a very private decision how much granularity they want to get and what should be a data set, what shouldn't. And then there we have an idea of archives. And you can look at them as a snapshot of a data set. Yeah, of course, the snapshot can have different meanings, but what I mean here that the current contents of the dataset are being written to some long-term file system and kept and won't be ever modified. So the dataset can keep evolving, but this snapshot taken at 11th of September will stay as it was. So it's long-term preservation. We support the Baggett format. It can be incremental, so it can reuse the unchanged data between snapshots. So you create a snapshot a week later, only one file was changed, then only one file will be, the rest of the files will be reused between incremental snapshots. And they can be monolithic or nested. I will show that in a moment. We support archive recall, so we can bring back a snapshot into the space. And together with everything that I have shown during this webinar, we kind of get a full data lifecycle management in Onedata, starting from acquisition of data, ingesting, uploading, pooling with automation, consolidation, aggregation in a single logical namespace, processing and analysis, annotating with rich metadata, which can be key values, so external attributes, JSON, JSON-LD, RDF, and to archiving and publishing. So most of that we have seen. And of course, from every point here, you can go back and evolve. The data can keep evolving, you can keep producing different versions. And for the last demo of today, I would like to show the datasets and archives in action. So I'm going back to the webinar space. And here's the photos directory. So I want to go into datasets menu. and establish a data set on this directory. I have the idea of data protection, data right protection, metadata right protection. So during the life cycle of a data set, you can say, okay, we don't want any more data changes. We are freezing that. We maybe want to only annotate from this point, but not change the data. Or maybe we can also protect from changing the metadata because we have finished annotation, and then we only want to retain this in this form. So you can manage it here. Let's say data right protection is enabled. So, well, yeah, I cannot upload any data because it's right protected. Using this tag, I can go back to the data set menu quickly, and the data set can have archives. So I want to create a new archives of the photos data set. It's gonna be a first archive. I'm not gonna show Baggit because we don't have enough time. And create. So this archive is being built. Yeah, it wasn't big, so it was quite quick. 17 files. It's ready. I can go inside and see the contents. So I will see the photos directory and contents of it. And it's held on a kind of a detached file system than the rest of the space. That's right protected. So you cannot change anything here. You cannot see it in this files menu. You have to use the dataset archive browser, or you can do it here. I can download it as a star. So we should see this archive with photos. And of course, it's gonna stay preserved as long as you wish to be used sometime in the future. Okay, so to make it a bit more interesting, maybe we'll upload something here. I have a favorites directory that also has a couple of photos. So I'm drag and dropping. It's right protected. I forgot to unprotect it. Okay, again, uploading the favorites directory. So I have my favorite images here. Maybe also upload some files to the main directory. So we're gonna have some more. Those ones don't have the metadata set because the workflow wasn't run for them, of course. Okay, so my data set has evolved. I have added something. And let's say I want to create another snapshot. Maybe before that, we can also say that favorites is also a data set. Why not? So we now have a nested data set. We can see it in the data sets view that there is a photos data set, and inside there is the favorites data set. And this one, of course, in itself, it's a separate data set, but it's kind of linked to the top one. And now when I go on and create an archive, I can say this one's gonna be an incremental one. So I want to create nested archives, which means for every nested data set, there will be a separate but linked archive created. If not, it will be a monolithic archive, but I want nested, and I want it to be incremental. It will be based on the one I've created a couple of minutes ago. And now only the files change should be should take the space here. And what we can see is files that have been preserved in the first archive now have two hard links. So they are preserved in the first snapshot and in the second snapshot. which means we haven't used any more space quota to create the incremental archive. We have only created a hard link to the file, which is on the metadata level. So, so that this way it's incremental. And for the new files I have uploaded, there is only one instance, let's say, of the file. There is no hard link because they were new, so they had to be copied inside of the new archive. And we can see that we have a symlink because favorites is a different archive. And in this archive, there are my 5 favorite images. Of course, when I go here and download as a tar, all those symlinks and hard links and everything are resolved on the fly, and you are served a monolithic tar archive with everything. So you get it. But in one data space, they are held as parts, kind of parts, saving your space. And if we go to the dataset browser here, we can see that favorites have one archives created. They are visible here. And so this nested archive has been created. It's a separate one, only with 5 files. So you can just use it as a complete separate archive. But other than that, it is symlinked in the parent archive. And this, of course, this granularity nesting, it very much depends on your needs, but we make it possible for you to organize your data in different ways and to save space, to save your quota. So yeah, it depends on the use cases. And that's it. That was the last demo, and we made it to the last Q&A session. And I can see another question has popped up. Is OpenStack bound to be running on AWS? Or is it possible to self-hosted? Okay, so you are asking about the Kubernetes cluster. Okay, so let's go back to this slide. So the Kubernetes cluster is just is deployed alongside the provider cluster. So it's the job of the site administration to run it. And we have kind of borrowed the notion of lambdas from AWS. I mean, we have reused the name because we liked it, but we are not using AWS lambdas. These are Onedata lambdas. So we have our own idea of lambdas, and they are basically Docker images with the Python handler built inside. Sometime in the future, we plan to make it more easy for users to define new lambdas. So we want to have a nice Python code editor inside Onedata UI. So you don't have even to create the images. You just provide the handler, but not yet. So it's not AWS related, only the name comes from it. Yeah, so it is possible to run the main node on a single server and or self-hosted K and ADAS. Of course, it is possible. We do it on the webinar provider. I have a small kind cluster that's a minimum Kubernetes instance, just running alongside one provider and doing all the job. How is the workload of workflows distributed? It's distributed on the very basis of how Kubernetes works. Because if you have a nice big scalable cluster, you can run jobs and they will be scaled to the needs of current workload. So new instances of function will be created or torn down as needed. And it depends how much resources and how many nodes you provide for Kubernetes. But this is something we depend on the natural behavior of Kubernetes to do that. And the next question, of course, if any of my answers are not clear, please write a follow-up in the box. Do I understand correctly that in order to protect the data within a dataset or archive, spaces where datasets or archive are used cannot be supported by a standard that is set as imported? Okay, let me process that. I don't think there is a conflict with that, because a space can be imported in a read-only or read-write manner. So you can have an imported storage on which you can also write through OneData. So I don't see why you wouldn't be able to use the protection. For me, they are kind of independent mechanisms. So one thing is being able to write into the space. If it's read-only, you can never write. So protection doesn't make much sense. You cannot write anyway. But for read-write spaces, I don't see a conflict here. Or maybe I misunderstood the question.
Thomas, is that answer your question? And if you want to talk, we can enable you to talk.
Thank you for your answer. I think now it's clear for me. Thank you.
Okay, good.
Nice.
Okay, I'm looking at chat and Q&A, and I don't see any more questions.
There was one remaining question from Yannick.
Of course. Thanks for
answer, or you need really.
Yes. I would like to answer that, of course. So yeah. Let me see what's that provider, because I don't remember off the top of my head. So maybe I see it here. Okay. So the suffix suggests it's in Spain. So maybe the admin wasn't very precise in setting the coordinates. So I guess this is just a mistake. Or maybe there is someone here who can confirm, but let's assume it's a mistake in coordinates.
Yannick, is there anything you want to talk? I enable you to talk now.
I don't know if you hear me, but yeah, no, not really. We went to see the product and we are interested. We quite a lot interest in France. So so this site in France, and I was rather surprised, but yeah,
it
looks like an error. Thank you.
Intriguing, right? Okay. Yeah, but hopefully we'll have some soon. Okay, thank you, and thank you for all your questions and nice. Yeah, those two. This is Strasbourg, right? Okay.
Yeah, that's right.
Yeah, thanks, Andrea, because I was wondering if it's yeah. Okay, so there are two. There's the left project and the other one. Okay, I'm very happy to see the nice words on the chat. Thank you. I hope. Oh yeah, we have one more question. I'm going to take it. So some few clicks on the interface can trigger very huge computational data events. Full replication of a huge data set. Is there any feedback that would warrant the careless click? Yeah, that's true. So if you go and, for example, say replicate here on a huge data set, you can be pulling terabytes of data for the network. And so, for example, yeah, you could go here and say replicate here, and there is not gonna be anything. Are you sure? So maybe this is a good idea to look at the very heavy operations and display an information that this is gonna cost a transfer of 1 petabyte. Are you sure? I think this is a good suggestion we can look into.
Okay.
Okay, so I'm waiting a bit more, but I don't see anything else popping up. Thank you for all your questions and for the interest. So we can close. You can meet me on the EGI conference. Oh, that's not good. So you can meet me on the EGI conference in Lecce. I'd be happy to talk with you. You can join our demo and talk for more DataHub and OneData stuff. And feel free to contact me. Of course, I wasn't able to go through everything. So if you, I'd be happy to give you some personalized demo if you have some certain use cases that you think could be solved by using OneData. I'll be very happy to give you more personalized demonstration. Thank you very much.
Thank you very much, Łukasz. Thank you. And Federico put the registration for EGI conference in the chat, and I see there's so many nice comments for the talk. And then indeed, I remember all this OneData development back to EGI Engage project in 2015. I was remember with Bartosz together. Very busy with the requirement collection, and then it's today I see all this development is so impressive, and both impressive and interesting, and to say the talk is very nice. Also, Nacho was in the chat and comment is become a dream of the developer. Then,
Yeah.
oh yes, you made people dream of OneData instead of money. So that can be is a really great success. I congratulations, and with this, I indeed with for our thanks all to our audience today, and then you can contact Łukasz, and he's very you see has supportive all the nice use case there. Is really the best support for the use case, and so that's made them so successful today. With this, I thanks again to Łukasz. Thanks to everyone joining us today, and you can find a recording, which we will send you the link later. And see you next time.
See you.